in section 1.1, I show you a few wave phenomena. So you have some physical picture about a wave. Now I want to introduce you some mathematics to describe a wave. And the equation to describe a wave is called wave equation, 这个波动方程式. And in this equation, you have a primary variable called psi, which is the moving amplitude of a wave. When I say moving, this means that the variable psi is going to be a function of time and position. So in the first term, this is the Laplacian operator on this psi, and Laplacian operator is an operator to do differentiation of this variable with respect to the coordinate x, y, z, for example. But the second term is the differentiation of this variable with respect to time. So this means that the psi is going to vary with distance or time. So if I plot this psi as a function of r, then I can have this diagram. The horizontal axis can be the position. And this means that the psi is changing over distance. But I could also plot this wave amplitude as a function of time. And so now the wave amplitude will change over time. So it's a function of time and position. And if you take into account the time and position at the same time, you start to see this curve move in space. And let me use the spherical wave as an example. The solution psi can have a spherical wavefront, and if you allow the time start to tick, then this wavefront can expand into space, and this is spherical wave. So you see the wavefront has a spherical symmetry, and this wavefront will propagate over some distance, but it takes some time to propagate. For example, from this point to this point, the time changed delta t, and the position r changed delta r. So if you look into the propagation direction, then we can define the direction of the wavefront vector. And now you take a ratio of delta r over delta t, then you can calculate the speed of the wavefront associated with this spherical wave. And this is the often called wavefront velocity. And later we're going to tell you that this velocity is also called phase velocity of a wave. So the general solution to the wave equation is called wave function, 也就是波函数. And 波函数 wave function has this form. The argument is always t plus minus r over u. And the reason to have such a solution is that this kind of solution properly describes a wave propagating in space. For example, when we look into a wave and we say the wave is propagating, the reason is that we focus our attention on one phase point on the wavefront. So suppose we pay our attention to this point, to this wave. And then this means that we are looking into a constant amplitude point on this wave. So they set this t plus minus r over u into a constant, say phi 0. And we call this as a constant phase point. Sometime later, the time will increase to t 0 plus delta t, and the position will increase from r0 to delta r, but we still set this argument to be a constant because we look into this wave at one constant phase point. And you're going to see that this pattern is going to move in space. And from this equation, t plus minus r0 divided by u to start with, and then at the later time the wave propagate to different location, then you can quickly derive this relationship, which is delta r equal to minus plus u delta t. So this means that the wave pattern is propagating. If you look into this point in space, then this point is going to propagate to a different location after delta t. So this u, in fact, is the velocity of this constant phase point. That's why we call this u the phase velocity of the wave. And this plus minus sign basically tells you the direction of propagation. And now let's go back to the example of a spherical wave. Because the wavefront expands over some distance and over some time, so the energy density will be reduced. So the solution to the wave equation has to be divided by r, try to conserve the energy for the spherical wave. Given this expression, you can properly describe the amplitude of the spherical wave propagating in space. So think about that the wavefront propagates from this point to this point, and at a particular point, the amplitude is the function of time and position. And the wavefront is defined through the constant phase by setting this argument to be a constant, t plus minus r over u equal to phi 0. So on the right hand side, this is constant, so you can always do derivative of r over t and extract the solution to be minus plus u, and this is exactly the velocity of the wavefront we just derived from the last page. And this the minus plus sign tells you the direction of the motion of the wavefront. For example, if the wavefront propagates outward, then you're going to have plus sign here. But if the wavefront propagates inward, then you're going to have minus sign in this expression. So this wave function describes a wave with a wavefront propagating along minus plus AR direction. AR is perpendicular to the wavefront. So in this session, I introduce you some mathematics. 第一步呢，我介绍了所谓的 wave equation， 也就是波动方程式。那这个波动方程式呢，有两个变数，一个是时间，一个是坐标。那这个 u 呢，就是这个波传播的速度，就是它波前的速度。那这个波动方程式呢，有一个通解，这个通解呢叫做波函数。这个波函数的形式，也就是它这个里头的这个变数呢是 t 加减 r 除以 u。那这个 t 加减r 除以 u 呢，描述一个波在空间里头传播。因为譬如说，我们把我们的眼睛就是注视着一个波前的一个位置的话，就是把这个 t 加减 r 除以 u 呢设定成一个常数。那从这个 t 加减 r 除以 u 等于一个常数上头，我们就可以算出这个波前移动的速度呢，就是 r dr over dt。那这个正负号只是代表这个波前移动的方向是在正 r 的方向或者是负 r 的方向。那这是第二个这个单元的几个重点。谢谢。